Greetings, fellas. I hope you are good. This is Medsan, your boy. If you haven't joined the family yet, please do the subscribe button and join the family for more of these videos. Remember, we are trying to unpack as much as you can. If you need us to do for you a topic, we will just do so. You'll do so by commenting. Okay, now we are continuing on our series on geometry. The first video we did the basis of geometry. Now we are continuing it from it. Okay, now we are answering questions that are requiring what. Okay, so now let's start with the first one, which is number one. Okay, on number one, we are looking for all the alphabets that are there. And remember, what are we given? We are only given these things here, this 27 and this 31. Okay, so how can I find anything from here? Okay, step number one, having that alone will tell me that we are going to use some few things that are going to help us to find the what the okay. I know some will say number one is confusing. Okay, if number one is confusing, guys, we'll try and start with it. The reason why we start with it, it's because we want to unpack and make sure that you guys get what we are looking for. Okay, so step number one here, we have such a theorem. Number one, we know that this is a center, right? So let's check. What can I find first here? Now this is why they find geometry so challenging, but it's not that challenging. Number one, this is a radius, hence that means here it's 90 degrees. That's the first thing. Number two, we know that also here it is 90 degrees. So I'm going to use what I have to find what I don't have. So that means angle T is equals to 90 degrees minus 31 degrees. Why do I say so? Say, why do you take that route? It's because we want to find all the possible angles. So I'll say 90 degrees minus 31. Okay, so that means angle T will be given by 59 degrees. 59 degrees. What was the reason? This was the radius perpendicular to the tangent. Okay, now we continue. This side we are looking for V. We're going to say V is equals to 90 degrees minus 27 degrees. This again, it's a radius perpendicular to the tangent. Okay, so you will say 90 degrees minus 27 degrees. You will have V to be equals to 63 degrees. Okay, that is what we are having basically, guys. Okay, hence here, that means here you will have also Y. Why do you have Y? It's because these are tangent from the same point. Can you see them? So that means you'll say what? Y is equals to 59 degrees. Y is Y equals to 59 degrees. First of all, before you will write what? These are angles opposite equal sides. Then before this one, you'll have to indicate that CB is equals to AB. Why? These are tangents from the same point. Guys, this is very important that you show such things. Okay, so I have these two angles. I can find Z. How can I find Z? Some angles of a triangle. So Z is equals to 180 degrees. Remember, now we are dealing with an isosceles triangle. Okay, so it's 180 degrees minus the 59 and minus the 59, right? So that's minus 59 degrees minus 59 degrees. Why? It's because of the sum of angles in a triangle. Okay, so Z is equals to, that should be 62 degrees. Okay, I found Z now. So I have V, I have T, I have Z, I have Y. Now what am I short with? I have to find W. Let me draw like this. So angle W is equals to angle V, which is equals to, what was angle V? 63 degrees. 63 degrees. Why is it so? It's because of the tan chord theorem. Okay, tan chord theorem. Then I'll find U. I'll say U is equals to T, which is equals to 59 degrees. Why 59 degrees? It's because again of what? Of tan chord theorem. Okay, then I found that one. Then I will say x is equals to 27 plus 31. That's again a tan chord theorem. Okay, so whenever you say 27 plus 31, you'll get 58. So x is equals to 58 degrees. Sorry, these are degrees. Okay, so that's what we have done on number one. So we have found everything, guys. We have found everything. So you see how we tackle and attack such problems. Okay, now I won't write the statements because of the space now for the other two. Let me just give you what are they equals to. Okay, so in this one we have 52 here. So that means A will be 2 times 52. So that means I know that A, it is what? 104 degrees. Why is it so? It is angle at the center is twice angle at the circumference. I hope you see that one. Angle at the center is twice angle at the circumference. That means also B here will be 52 degrees. Tan chord theorem. Can you see how we mangled and deal with such problems? Okay, I have A, I have now B. Okay, what else can I have? I can have the two E's because they are equal. Why? It's because here I have 90 degrees. Can you see it? So that means each E will be what? Will be we will say 90 degrees minus 52. Then you'll have 65 divided by 2. That means each one, it is what? 32.5 degrees. Okay, so each E is 32.5 degrees. So that's how we have found it. So to find G here, you are going to say 104 plus 32. 104 plus 32.5. You will have G to be 136.5. reason it's exterior angle of a triangle. Guys, as I'm saying them like this, please note them down and check again. Okay, therefore it is easy for us now to find F and G. Okay, so guys, that is how you mangle and do everything here. Okay, so for D you will use this triangle here for D. So you know that 32, that's 65, so that means D again will be what? Will be 65 degrees. Why? Angles oppose equal sides. Okay, therefore to find F you can use that triangle now. Okay, so we'll have 32,5, you have 52, you have 65, you are looking for F. So you are going to say 180 degrees minus 32,5 minus 52 minus 65. Hence you'll find F to be 30,5 degrees. So that's how you do such problems, guys. Okay, I would have written it down, but because of space, it's already messy in my screen, so I cannot make it more messier than this. Okay, now let's go to number 3. Number 3, this is 50. That means X here is 50 degrees because of tan chord theorem. Tan chord theorem. Okay, therefore if it's like that, then what else can I find? I can find Y here. So Y will be equals to 180 degrees minus 70 degrees minus 50 degrees. Okay, sorry, it's 180 degrees minus 70 degrees minus 50 degrees, which will give us 60. So that means this is 60 degrees because of the sum of angles in a triangle. Okay, then if you have something like that, this one plus this one is 180 degrees. Do you remember? Opposite angles of a cyclic quad. Hence that means Z will be 180 minus 60 degrees. So Z will be 120 degrees. These are what? Opposite angles of a what? Of a cyclic quad. Okay, now if you have that one, again you can find this one, because this one is equals to that one according to tan chord. So W is equals to 70 degrees, and that is a tan chord theorem. Now my advice again, guys, make your diagram to be dirty with correct information. Don't just dirty your diagram just for the sake that the teacher said it must be dirty. Dirty it with the correct information. While you find this, try to write with a lead pencil that this is the reason, this is the reason, so that you don't forget the reasons. Because a statement with incorrect reason, that means it's incorrect. And again, a correct reason, the wrong answer, that's also incorrect. Okay, this was just a messy problem. Let's try and look at other problems. Now we are dealing with these problems so that we answer the questions. Okay, we have now this problem here. Now this problem here gives us a lot of information that will help us to do what? To just answer any question. So it is very important, sorry, Excuse me on that one. So it is very important that we start on the information given. So A, B, C, D lies on the cycle. Okay. Here is A, here is B, here is C, here is D. In other words, they are telling us that this is a cyclic quad. So we just know this is a cyclic quad. So automatically we go and expect opposite angles. We expect exterior angles. We expect angles in the same segment. That's what we are expecting, because they have told us about this cyclic quad syndicately. There are many vertices. Why do they tell us about these for? It's because they lie in the circumference. That means that it is a cyclic quad. Okay, they continue and say PCD. PCD is a tangent. Wait, they told us now about what? A tangent. Now, you being a good student, you know that we have a tan perpendicular to the radius. We have a tan chord theorem. Then we have tans from this common point. So you list all these things that we are expecting, right? Then they said E is a midpoint. Wait, E is a midpoint. Once E is the midpoint, that means we have theorem number 1. So you write theorem 1. Not just theorem number 1, it's converse. Okay, then they told us about the angle, and then now they continue and say O is the what? Center. So you write here center. Okay, since in center, you know that we have theorem 1, line from the center perpendicular to the chord, or to the midpoint of a chord. Theorem number 2 says angle at the center is equals to 2 times angle at the circumference. Number 3, we have angles in the semicircle. So can you see that automatically they've given me almost all the theorems here? Okay, they have just given us all the theorems. Since they have given us all the theorems, now this is up to us to go and check, what do we have? Let's start with the first one. We're given a cyclic quad. Let's go and check. If this is a cyclic quad, we know that this one is equal plus this one. They are giving us 180 degrees. Also these ones and that ones, they are in their sum, they give us 180 degrees. Do I have the other one? Do I have the exterior? No, I cancel it out. Same segment? No, I don't have the same segment here. So the only one I have is opposite angles of a cyclic quad. So this is how, guys, you answer such geometry. Then you go for tangents. Tangent. Do I have a tan radius? Oh yes, I do have a tan perpendicular to the radius. Here it is. Here it is. So that means that one is pass. Do I have a tan chord? Yes, I have a chord here. So that means this one is equals to that one. Okay, again, this one is equals to that one. It's tan chord theorem, guys. Okay, do I have tangent from? No, there's only one tangent. This one is out. Okay, then I go for number 3. Theorem number 1. Oh, I'm told that this one and this one, so that means this is the midpoint. So that means this one works. Angle at the center, let me check. Angle at the center is twice angle at the circumference. Yes, I do have it. Angle at the center is twice angle at the circumference. You see how I'm indicating these things, guys? So these ones will help you. Do I have a diameter? No. Okay, so that means this one is out. So let's try and now check and put the angles there and check. We have A2. A2 is here. It is 18 degrees. C1, here is C1. It is 43 degrees. Now let's go for it. They are looking for what? A3. Where is A3? There is A3. So A3 is going to be equals to, I'm going to say what? I'm going to say 43 minus 18. 43 minus 18 degrees. That means 43, A3 is what? It is 25 degrees. Why? It's because of tan chord theorem. This angle, we said it's equals to the whole of that one, but this one is 18. So I'm going to say 43 minus 18 to get this one. So I've already gotten it, and I do write it down. That is 25 degrees. Okay, now that is going to work for me. C3, where is C3? That is C1, C2, and C3. So now they're asking me for C3. Can you see an isosceles triangle here? This radi and that radi. That means this one is equals to this one. So I would say what? C3 is equals to A2, which is equals to 18 degrees. Not 18 degrees. Reason it is angles opposite equal sides. Okay, I hope now you are following me, guys. Okay, so I'm trying to digest this with you guys so that you see it. Then we continue. They say AOC. AOC. The whole of A. The whole of A. How can I find the whole of A? I have this one, I have this one. So that is some angles of a triangle. So this is going to be what? It's going to be 180 degrees minus 18 minus 18. So this one will be 144 degrees. Why is 144 degrees? It's because of the sum of the angles in a triangle. That is how we find it. Okay, now we continue. They are now looking for angle D, the whole of angle D. How can I find the angle D? Angle at the center is twice angle at the circumference. Do you remember that one? So that means I'll take 144 and times it by 2, because this is an angle at the center is twice angle at the circumference. Can you see it? Angle at the center is twice angle at the circumference. I did not indicate that one, okay? That is very important as we are doing problems. Okay, so this one, it is what? This one, it is 100. So I'm going to say 144 is equals to 2 times D. Since I'm looking for D, I'll divide by 2, divide by 2. Then angle D is equals to, what is 144 divided by 2? It is 72 degrees. So that means D, it is 72 degrees. Why? It's because of the angle at the center is equals to 2 times angle at the circumference. Okay, that is very important, guys. I'm answering with you and you are still with me. We show all the angles, right? So PCA, where is P? Here is P, C, and then they say A. So they are looking for the whole of this. They are looking for C4 and C5. Okay, since they are looking for C4 and C5, let's check what we have. Okay, that is going to allow us to get what they are looking for. We have this one. Having this one means I can find also that one. All right, then what else can I find here? Okay, but in an easier way, I know that that is 90 degrees. So that means PCA will be 90 degrees minus 18. That is very important. 90 degrees minus 18 degrees. Why is it so? This is going to be also 72 degrees. Okay, that's going to be 72 degrees. Why do I say so? It's because of the tangent perpendicular to the what? To the radius. This was 90 degrees, do you remember? And I do have that one, small one. Then I'm looking for this one and this one. Okay, then we continue to ABC. ABC, opposite angles of a cyclic quad. Remember, angle D is 72. So I'm going to say 180 minus 72. I have 108. So this one is equals to 108 degrees. Why? These are opposite angles of a cyclic quad, which are supplementary, right? That's what I found, guys. Then prove that O1 is equals to O2. This is very important, guys. Prove that O1 is equals to O2. How can I prove that one? How can I prove that O1 is equals to O2? Remember that that was a midpoint, right? So since there was a midpoint, that means step number one to prove this, I'm going to say number one, let me prove it here. For me to prove that this one and this one are equal, I would have to prove that this is 90 degrees. Angle E is 90 degrees. How can I prove that one? Remember, we said the converse, and they told us about the midpoint. Do you remember that one? So what are you going to say? You are going to say, since EC is equals to AE, why are they equal? It's because line from center. Okay, let me remove this. Line from the center is what? To the what? To the midpoint. Right? Line from the center to the midpoint. What does that mean? It means therefore that angle E 1 is equals to angle E2, which is equals to 90 degrees. Okay, therefore that means if this is 90 degrees, remember this is 90 degrees here. Let me indicate. Maybe you might not see what I'm trying to say here. If this is 90 degrees here and this is 90 degrees, it means now I have this one and this one. That means therefore OB does bisect. It bisects. What's to bisect? Is to separate something that is full into two equal parts. So it bisects what? Angle AOC, which means that what? O1 is equals to O, sorry, that is Q, that's not O2, which is equals to 144 divided by 2. What is 144 divided by 2? That will be 72 degrees. That is how I have proven it. Okay, now since it's so, they said now to me determine size of C5. Here is C5, right guys? So having C5 means I now need to go and check what is A1. How can I find A1? Remember, I now have this one. Having that one alone, and I have this one. This is 90 degrees, and this is 90 degrees, right? And I said this one bisects, right? So that means since angle B was 108, so that means 108 divided by 2. 108 divided by 2, it's 54. So hence A1, I'll say A1 is equals to 180 degrees minus 90 degrees minus 54 degrees. So A1, wait, before I say so, this is a sum angles of a triangle. Okay, so I'm going to say 180 degrees minus 90 degrees minus 54 degrees. This is what? This is 36 degrees. Hence, C5 is equals to A1, which is equals to 36 degrees. Why? That is tan chord theorem. Okay, so that's how we go about answering such problems. I know there was a bit of mess. I'm really sorry about the mess, but this is how you digest and do such problems. Let's do more so that you see what I'm trying to say. Let's check this one. I love this one. Now. This is a keyword. This is a keyword. It is QR. Where is Q and where is R? Here is R. Guys, once you see the word produced, it's another keyword that tells you that there is an exterior angle of a cyclic quad. 2, there's an exterior angle of a triangle. Number 3, it tells you about the what? The angles in a what? In a straight line. So it tells you about these 3 things. So if you check there, you can observe the exterior angle of a cyclic quad. Okay, so those are the things that you need to check at. Okay, so now let's continue. Meets the tangent US at S. Okay, yes. And touches the circle at T, yes. And okay, we're given, okay, yes, 31 and 20. Okay, now they said to us determine the size of QPT. They are looking for that whole angle. Okay, that whole angle, remember here is our O and this is our diameter. Our diameter subtend 90 degrees in the circumference. So that means this one, it is 90 degrees. Why is it 90 degrees? Angles in a semicircle circle. Angles in a semicircle. Okay, they continue and said find QRT. QRT, the whole of that one also, it is equals to 90 degrees. Why? Angles in the semicircle. So I have found that one. Okay, now they continue and say what? QTU. So the whole of this one again, it is 90 degrees. 90 degrees. Why is it 90 degrees? It is the diameter perpendicular to the tangent. Diameter perpendicular to the tangent. Okay, that's what I'm having. Now they said to us, determine the angles A until Z. It's quite many of them. Okay, it's quite many of them. But we can do so. We can say K is equals to, what is 90 degrees? 90 degrees minus 31, which will give us 59 degrees. It is diameter perpendicular to the tangent. Then we go and check what E. E is 20 degrees, tan chord theorem. Okay, I hope you guys are following me, right? So if it's so, again I will have is that A? Yes, A. A is equals to 180 degrees minus 90 degrees minus K being 59. So A is 31 degrees. Why is it so? It's because of the sum angles in a what? In a triangle. Okay. I'm trying to digest them one by one so that we are able to see them, guys. Okay. So that's what we have for now. We can find F. F is equals to 180 degrees minus 90 degrees minus 20 degrees, which is giving us 70 degrees because of the sum angles in a triangle. Okay, so we are trying to digest each and every one of them, guys, so that we see what we really have. And you can see here, let me go here on the side. You can see that angle I is equals to angle A, which is 31 degrees. Y angles opposite equal sides. Okay, which means also J is equals to 20 degrees. Angles opposite equal sides. Okay, then we continue and find M and L. M is equals to, we are going to say 180 degrees minus, we said alpha is 31 minus 31, which is 118 degrees. Why? It's because of the sum angles in a triangle. We continue and find L. L is equals to also 180 minus 20 minus 20, right? which is equals to 240 degrees. That is a sum angles in a triangle. Okay, therefore we can find n is equals to 20 plus 20, which is 40 degrees. It's an exterior angle of a triangle. Then you can find C. Which is equals to 31 plus 31, which is 62 degrees. It's an exterior angle of a triangle. So we are trying to digest everything. So now having so, now I can find what? I can find, okay, I've found everything that side. Now I'm trying to go down that side, okay? So I found F, let me indicate, I found all of these. I found this one, this one, this one, this one, this one, that one, and C, I found that one. So I'm left with D. Yes, D, G, H, and Y, X, Z, W. Okay, so let me find those. Guys, you remember when you do this, you give yourself time, because these problems like this, they train you to find angles as quickly as you can. Okay, now let's check. This one, 31 will equals to this one. So that means I'll find B. B will be equals to 31 degrees. That is tan chord theorem. Then also E is equals to D. So that means D is equals to, what is E? It's 20 degrees. That is tan chord theorem. I hope you guys are following me, because I'm trying to be as slow as I can, guys, so that we are able to find such problems, okay? Now, let's check once again. Now I'm done with this one. Now, automatically, I need to find what? I need to find H and G are equal. So H is equals to G, which is equals to, when I say 180, I'm now using that bigger triangle. I'll say 180 degrees minus, what is C, what is N? Minus C, my C is 62 degrees, minus, what is my N? It is 40 degrees. So these are equals to 78. Then they will say divide by 2, which is equals to 39 degrees. Why do I say so? The reason I'm saying so, it's because of the sum angles of a triangle. Sum or one will say these are angles opposite equal sides. Okay, so I've just found them very quickly. That means automatically now the only thing that is left here, it's for Y. I have N, I have H. So Y is equals to, I will have 180 degrees minus h, which is 39, minus n, which is 40. So that is 101 degrees. Why? It is sum angles of a triangle. Okay, then I have y. That means I can find z, angles in a straight line. So z is equals to 79. Why is it 79? Angles in a straight line. Okay, if it's so, z also can find x. So x is equals to 101 degrees. Why so? You can also use vertical opposite angles. Okay, so I found everything, guys, that was being asked for from that diagram. Okay, now I know it took time, but we are getting there. Okay, now let's go to this one. We are trying to digest finding angles because we need to find them. In the figure below, this is a tangent to a circle at center O. Okay, this and these are equal. Once they say this and these are equal, that means this angle and this angle are equal. Okay, and since there's a tangent, that means here there's 90 degrees. Okay, and this is a tan chord theorem. So that means I found this one, B1, angle B1 is equals to 40 degrees, tan chord theorem. Tan chord theorem. Okay, that means also D2 is equals to 40 degrees, angles opposite equal sides. Okay, then we can find angle C, which is equals to 180 minus 40 minus 40, which is 100 degrees. This is a sum of the angles in a triangle. Okay, then from there you can see angle at the center is twice angle at the circumference. So that means angle O2 is equals to 200 degrees. Why is angle O2 equals to, that is angle at the center. At the center is equals to 2 times angle at the what? At the circumference. Okay, that is very important. Then finding that means I can find also O1, which is equals to 160 degrees, and I can say angles around a point. Remember, angles around a point, they always give us what? They give us 360, right? Then finding O1 will also give me D3, right? What is D3? D3 is equals to 90 degrees minus 40 minus 40. So it's 90 degrees minus 40 minus 40, which is equals to 10 degrees. Why? These are radius perpendicular to the tangent. Okay, I found that one. What else do they need? I think I'm done what they are looking for. I'm now looking for A. Now A is equals to angle at the center is twice angle at the circumference. So you are going to say what? You are going to say 160 divided by 2, which is 80 degrees. 80 degrees, you're going to say angles at the center is equals to 2 times angle at the what? At the circumference. So I am done doing this one. You know, it now becomes fluent because the more I do them is the more I can see them. Okay, now let's check another one. I want us to go to a point where I'll say no. I now know what to do. In the diagram below, A, B, C, D, and E, wait, there are 5. Hence, that's not a cyclic quad. Okay, such that they gave me parallel lines. Wait, parallel lines. So in parallel lines, I look for fun. Okay, and then they said BE and DE are what? Are produced. You know the 3 things you check here: the exterior and the exterior and the angles in a what? In a straight line. Okay, and then they gave me a tangent. I have 3 theorems under a tangent that I'm checking for. Okay, so let's go for it. So that means this one is, that means also AE1 is 68 degrees. 68 degrees. Why? That's a tan chord theorem. Tan chord theorem. Okay. Then B3. Where is B3? Oh, here is B3. Wow, those are alternate angles. Can you see? The Z or the N shape. So that means B3 is equals to 68 degrees alternate angles. Why do they alternate? It's because AE is parallel to BC. Okay, and then D1. Where is D1? Here is D1. Remember, it was produced, right? So that means that one is equals to 68 degrees and exterior angles of a what? Of a cyclic quad. Okay, then they continue and say E2. Where is E2? Here is E2. Okay, so E2 is going to be 68 plus 20, which is 88. Why did I say so? It's an exterior angles of a triangle. Can you see that one? Let me indicate it. Here it is. Okay, so here it is. Okay, that is it. Then E3. Where is E3? There is E3. So I can find E3 by some angles of a triangle. Okay, when you sum angles of a triangle, I'm going to say 180 minus 68 minus 20. Then I have E3 to be 92 degrees. Or you can use angles in a straight line since it's produced, guys. Okay, so that means this is a what? Angles in a straight line. In a straight line. Okay, sorry guys about all the messes. I'm trying to do it as quickly as possible. Angle C. Now how can I find angle C? This one and that one. Exterior angle of a cyclic quad. So that's 92 degrees and exterior angles of a cyclic quad. Okay, Then from there, I'm going for D2. Where is D2? Here is D2. So what is D2? So D2, I'm going to say 180 minus 62. Okay, so that means it's 118 degrees. I can say angles on a straight line. Or one can say it's opposite angles of a cyclic quad. Okay, so guys, I've answered all the questions now. Let's check the other one, guys. Now you see how I tackle the problems. The keywords, they give me clues what to look for. Okay, now let's check this one. I hope this one will be the last one in this session. They said O is a center. You know, three theorems under a center passing through 1, 2, 3, 4. That's a cyclic quad. A, B, C, and D. Guys, that's a cyclic quad. They cannot defeat me on that one, because once they give us these points, there are many vertices there. But why do they just give us these points? It's because there's a cyclic quad. Hence, I know now that this is 20 degrees angles on the same segment. Okay, but let's continue. They say A, B. Oh, wait, fun. Why do I say fun? It's because of the parallel lines. Okay, and I can now see that this is also 20 degrees because of alternate angles. Alternate angles. Okay, now let's say they say to us find C1. Oh, okay. Angle C1 is equals to 20 degrees. These are alternate angles. Why they are alternating? It's because AB is parallel to CD. O1, where is O1? Oh, there is O1. Angle at the center is twice angle. Okay, O1 is equals to 40 degrees because of angles at the center is equals to 2 times angle at the circumference. Okay, they continue and look for D. We now know that angle D is equals to 20 degrees. Angles in the same segment. Angles in the same segment. Okay, they are looking for E1. Okay, or E1, it's an exterior. So E1 is equals to 40 degrees and exterior angles of a triangle. Okay, now number 5, they say why AOE say, okay, it is A. Where is A? Let me highlight. This is AOEC. I said, why is this a cyclic quadrilateral? It's because E1 is equals to O1. Look at E1 and look at O1. It's because of E1 is equals to O1, which is equals to 40. And the reason here will be what? A converse of a what? Of angles in the same segment. So that's the reason, guys, there. Okay, so guys, make sure that whenever you do these problems, you do not rush. At the same time, you check the keywords. The keywords have all the information on how you should answer the problems. Thank you guys. We will meet again on required to prove.